Okay, here we go. Find the magnitude and direction angle of this vector, which has a horizontal component of 6 and a vertical component of -6. Write the answer in trig form. Trig form is what we're talking about. That's when we have the sine and the cosine values written in the component. Okay? So first things first, good problem solvers, draw pictures. I've got 6 and -6. Remember, this is what we call linear combination form. Linear combination can be written in component form. I just drop the I and the j and put the two numbers in these two spots for the component. So I move over 6, I move down 6, right? Start at the origin when I'm writing in component form. So I know that this displacement, or this component is 6. I know that this component is -6, right? To write the answer in trig form, we need theta and we need the magnitude, right? We're looking to get this format. We're looking for this. We need the magnitude, we need the direction angle. So if I jump through the hoops here, I can find this pretty easily, right? Again, I don't know how good you are with your special right triangle trig, but if this is 6 and this is 6, then this is 6 root 2. If you don't want to do that, you can say 6 squared plus -6 squared is equal to, we can call it c squared if you want. 36 plus 36 is equal to c squared. This is 72 equal to c squared. We get the square root of 72 is equal to c, but 72 has a perfect square factor of 36. So that's where we get our 6 radical 2 from for our magnitude. Okay? So we have our magnitude of 6 radical 6. We need theta. Remember, theta is this. It's the direction angle in standard position. But we're not going to find that without a protractor, right? So instead, we're going to find this slice and then figure out how to get that piece from it. In order to find this angle, if we know these two sides, this is where the tangent ratio comes in. Tangent of theta is equal to the opposite side over the adjacent side. So we get theta is equal to the inverse tangent of -1, right? 6 over 6 is 1, one of them is negative. Type this into your calculator if you want. You shouldn't have to, because we've talked about angles that have a tangent value of 1. We talked about that last chapter and in chapter 4. Okay? But when you type this into your calculator, what's it going to say? -45 degrees. Okay? Is that the direction angle of this vector? No, that's that angle right there. So the 45-degree angle is this slice, just this slice right here. The direction angle of the vector is this angle. Okay? It's the Pac-Man piece. So we take 45 degrees, we're 45 degrees short of completing this circle, so we take 45 and we subtract it from 360, we get 315 degrees. So the trig form of this vector, we've got 6 radical 2 for a magnitude and a direction angle of 315 degrees.